Welcome to another video about Reflexis Flow and our Indigo toolset. This video is a bit of a quick follow-up to the getting started video I did the other day. In that video I showed you how to create a working installation of our software. We usually call a working installation an instance. And this is the particular instance I created during that session, and right now I'd like to do a quick run through of the folder structure. So if you haven't seen the earlier video yet, please do so, because otherwise this probably won't make that much sense. But if you have, let's have a quick look at what's what. So these files by now you should know. This is the actual interpreter, the Indigo interpreter that's being used for the web sessions. And as I explained earlier, there are actually three interpreters, or well, there's just one interpreter, but there are three flavors. There's the web interpreter, which is this one. There's a worker interpreter, which sits in the bin folder here. The worker interpreter is used for longer running processes. So for example, one of the things it facilitates is sending emails or interacting with web services. So the third flavor that we have is the actual command line interpreter, which is called I. So we have I, we have Indigo and worker, and they differ in capabilities in some respects. That's not very important right now, because in this session I'd like to just run you through the folder structure itself. So this is the package which should reside next to the interpreter, so it knows where it is, and that leaves us with the folders. The folders either contain code, so working code, Lua scripts, or data, and some folders can contain both. So if you look at Lua scripts, then they should be either in the app folder, or in the for app obviously stands for application, or in the lib folder, which stands for library. So it's a fairly subtle distinction. The way we look at scripts in the library structure is that these are reusable scripts, so stuff that you can. So a library script is something that you could potentially use in different applications, in different projects, and these are the scripts that you load using require. So usually we structure these scripts by creating subfolders. So in the earlier video, I created this ABC folder, which held the test library script, but it was just a demo. And the subfolders here obviously can be nested as deeply as you'd like to. We tend to stick to just one level, but having folders here is a nice, having subfolders here is a nice way to structure your library script, and most of our own library code is structured that way. So these were three subfolders that were created by the deploy utility, mostly to give you an idea of where these particular type of scripts go. So this one here, lib task, is usually the place from where flow parts are located. So whenever, and again, as with library scripts, we tend to group these into folders. So in our setup, there are UI parts, there are database parts, and you can organize them like this, or come up with your own structure. But having a structure helps. The conduit folder, conduits are a fairly recent feature, but our platform contains some standard conduits, and obviously you can create your own conduits and enhance our platform and the capabilities of your own flows using them. And the same holds true for type handlers. So again, this is not about explaining conduits or type handlers. This is just to give you a quick idea of why these folders are here in this instance that was created automatically for you. So that was the lib folder. So the application folder, this is the folder that holds actual application scripts, and whenever the Indigo interpreter is run, it'll look for a script here to start. So in the release package, if I open it up just briefly, you'll notice here that there is actually a flow script packaged in this package, and this script is the one that runs whenever your flow is executed. But using our libraries, using our toolset, you could actually create your own web applications completely from scratch, not using Flow, but just using the Indigo toolset. And if you do so, this is where you'd need to place the script for it to be recognized. The start folder is the folder that holds starter scripts. So starter scripts are we came up with a special mechanism to control whenever a session is initiated. It would have been easy to just say, oh, every flow contains its own login logic. But we realized quite some time ago that it's not a very efficient way to go about it. So because if you do so, then Flow runs at every login attempt, and it would be preferable to be able to log in using a static HTML page. And also not to redo your login logic for every flow that you create. So that's why we came up with a fairly generic starter script that checks a username against the user password, etc., etc. And there's also a standard local starter that allows developers to quickly start flows on their own local machines. But people can create their own starters using their own logic, and I should probably do a video about that maybe soon. Anyways, if you do have starter scripts, your own custom starter scripts, this is where they need to go. WRK stands for worker. I showed you the worker executable earlier, and as I said, the worker is usually responsible for longer running stuff. So the Indigo interpreter takes care of all the, the regular, creating responses for web requests. But whenever there's something that potentially takes a lot longer than a few milliseconds, we tend to hand that off to the worker. And whenever you start a worker, you can supply it with the name of a script, and it'll look here for that particular script. And as with library scripts, you can have subfolders here as well. So if you have different projects, you can have different worker script for different projects, and then at that point it makes sense to organize things. Right, so a folder for the starter scripts, a folder to hold worker scripts. This is where the application scripts go. The bin folder we've already seen, so this is the worker itself. This is the executable that's responsible for laying out, it's responsible for helping visualize flow definitions. So it takes care of laying out the graphs. And you only need it if your instance is also used to model things using our modeler. Right, that leaves us with the data folder, which I'll come to in a minute. The dev folder is a folder that we ourselves use for development stuff. So right now it's completely empty. The thing here is just a demo script that I created in the earlier video. But on my local, I find it convenient to have stuff like Lua documentation, SQLite documentation on my own local machine and not have to go onto the internet, because then you can use it when you're not actually online. What we do is just place that stuff here, and it's in a fixed location. The etc. Folder is something that we use to collect notes, and the util folder is important because this is where the command line version of Indigo. So this is where the I executable will look for scripts. And again, if you look at the release package, well, not this package. If you look at the I package, open it here. Look at the script table. You'll notice the util prefix here, and that actually tells you that devutil can be used for should go here as a location to place your own utility scripts. There's actually another place where you can put utility scripts that the I command line interpreter will pick up, and that's the project folder structure. So if I have a project like test, and I put in a script like blah. Let's do something. Then, let's go here. Yes, it's configured right. And right now I created in my project folder structure a project test, and there's a tool script called blah, and I can run that using this. So again, demo here was located in dev-util. It'll pick up scripts here, but it'll also pick up scripts that you place in project folders underneath the project root. And we found that that's actually fairly convenient. Years ago we used dev-util exclusively for utilities, but since every project that we did had 1 or 2 or 5 separate utilities, it all sort of got cluttered up in one folder. And at that point we realized that, you know, sometimes it's convenient to have utility scripts organized by project. And we found this is a nice way to do it. Obviously you could also have a project structure underneath dev-util, but this is another way to go about it. So that leaves us with just one other folder, and it also turns out to be the folder holding the largest number of subfolders. So let's run through them. CFG stands for configuration, config, and it's actually empty, which in retrospect probably wasn't such a good idea, because this means that also the SMTP configuration is missing from a standard deploy. But usually we use this folder to store configuration files for stuff we write. Like I said, the emailer uses something called smtp.cfg. It'll read it from here, and you can put in stuff like host and from field, as well as user and pass fields to communicate with the SMTP server you'd like to use for sending emails. So the password field should be hashed, and but that might be something for a different video. Anyways, some of the utilities we use configuration files here. I intend to do a video about our working environment. So how do we use our own tools and go about it? And some of those tools actually use configuration files in this folder as well. In any case, this is the file that we use to store configuration data. The FLW stands for flow, obviously, and you've already seen this one in the earlier video, because this is where I placed the default flows that we release. So here are the modeler flows, a basic flow template, and some of the system databases. And the most important one is the task database, because this one acts as the repository for flow definitions. So whenever you run a flow, it's not the text definition that's being used. It's actually the sort of compiled definition that's stored in this particular database. I won't go into explaining all the other databases. That might be a topic for another video if there's any demand. This file is being used by the local menu that you may have seen if you've watched the quick demo video that I did. So these folders are used by The modeler, so the flow-based flow modeler, it's model flows. This folder stores the SVG files, which are basically the rendered flows. And this folder is used to store stuff that you delete and might want to recover. I'm not actually sure if it's still being used, but it's there. So, back to the data root. SES stands for session, and this is where session files are stored. Before 2017, a session file was just a single file, and it would hold both metadata about a session, like what's the client's IP, when did it start, how many requests, stuff like that, as well as the data for the session, which we tend to call the session context. So starting last year, starting with Flow 2017, we actually split these up into two different files, which actually is a very nice optimization, because you don't always need to. Previously, whenever there's a request, all the session data was read. So and right now, using the new setup, sometimes the system finds that it doesn't need to load the actual data, and so that saves time, which is nice. Probably another good thing to mention, if you're a developer using and working on a flow, developing an application, one of the things that you may find convenient is simply opening the file belonging to your particular session. Like I said, there are two files, and the file that's probably most interesting is the CTX one, because this is the data space, the session context, and what you'll find if you open it is that it's essentially data written out in Lua syntax. So it's very easy to read. If you have a fairly smart editor, then you can use folding, as I'm doing right now. And you can track and keep an eye on what your web application is doing. So in this case, this is a session file from the flow modeler that I demoed earlier. So it's actually a fairly large session, since it's almost 12 kilobytes. But it should be obvious that keeping sessions this way is a really good way to debug stuff if you ever have a need to. Right, next one, SPL. SPL stands for spool, and this is, if you look into it, this particular folder, you probably will find that it's usually empty, and that's because this folder is used by Flow to store pages that it needs to send to clients, and whenever the page has been sent, it's deleted from this folder, so no traces remain. But that's why this folder is needed. It's being used for pages. The log folder you've already seen earlier. It holds 3 system databases. The catch one I'll skip for now. The block database is being used by the starter logic. Whenever someone tries, whenever there are too many failed attempts to log in, the starter logic will block login attempts for a particular amount of time, and the block database is used to manage that, to facilitate that. The alert database is an important one because it stores everything that goes wrong in the system, and I will show you in the working environment video that I'll probably make this week, next week, whenever. That there's also an alerts feed that you can use to monitor systems. But all the alerts that occur are stored here, and in this case I can open it up. There's nothing here because it's a clean, freshly created instance, and nothing ever happened here, so there are no alerts. Right, so PKG stands for package. This is where we tend to store manifests. So you've seen in the root folder here that our system uses files like these to store both code and data. So library scripts, application scripts, pretty much whatever you can think of. Resources can be stored in a package, and it's a fairly efficient way to easily maintain an instance, because if you've been working on a particular web application on your development machine and you need to update an instance on a server in a production environment, or you need to move all the new code or the updated code to a test environment, you don't need to do that, script by script. So packages have become a really nice way to bundle everything together and then move it to a new instance, or update the new instance. And to create these packages, we have a separate system, a pack system, and there's also a package update utility. And these two utilities can be used to build these packages, and they use manifests to figure out what should go into these packages, and that's probably another video I need to make, but the process has been documented a couple of years ago, so you can read up on it if you want to. And in any case, .package is where we tend to store the manifests. So pub, that's actually one that shouldn't be here. It's part of it's actually part of some ongoing developments for the next generation engine that we're still working on, and as preparation, I sort of snuck it in here by accident, but it's not being used by the current version of Flow, the current official version of Flow. Q is short for queue. And queues are folders that are used to communicate usually with worker scripts. For instance, there is an outbox folder here, and this outbox folder will hold all the emails that the email worker needs to send. And similarly, WS stands for web service. All the requests that should go out are stored here, picked up by the web service worker, and whenever there's a result, the results will be stored here as well. And We're using queues because it's really low tech. So it's just files holding data, which I think is good. Low tech is better than high tech because it tends to break less often. But the other important bit about queues is that it's also persistent. So if the system goes down for whatever reason and there are still emails that need to be sent, they'll still be here in the, well, not here, but here in the outbox queue. And whenever the emailer, the email worker script is started again, it can pick up from where it left off, and nothing is lost. So that was one of the main design decisions behind having these queues. You may have noticed that there's also an outbin folder. The outbin folder is actually exactly the same as the outbox folder, but everything that's stored in outbin will never be sent. And you can actually control how the email system will go about it. So in the boot script, there's a disable email setting, and by default, well, not by default, I'm not sure what the default is, but at least here it's disabled. And if you disable email, all the emails that you try to send will be stored in .queue, not outbox, but outbin. So that makes it fairly easy to debug stuff. So instead of having to use, your own email addresses or whatever, you can simply check the outbin folder and see if all the emails that you think it should send are actually being sent. And that's what the disable email configuration setting does. Okay, we're nearly there, I think. Let's see, CFG. Oh, I think I've been toying with the order. So we've had this one configuration, flow. We've also had log package. This one's not being used. Queue, session, spool. So what remains are inc and upl. Inc stands for incoming. Whenever a flow has a file upload input and the user uploads a file, it'll end up here in the incoming directory. And the upl folder, upl also stands for upload, so that may be a bit confusing, but this is something that we added much later. The upl folder actually holds data about what a user is allowed to upload. So if you're familiar with Flow, then you know that you can actually configure what sort of uploads are allowed, how large they can be, etc., etc. And well, whenever you do enable an upload for within a flow, this folder will temporarily hold a specification of what's allowed, and at some point everything will be cleared out. So I think that wraps everything up. Just a quick check: configuration, flow, incoming, the log databases, the package manifests, not being used yet, the queues, the session files, spool files, and upload specifications, all part of the data folder structure. So let's see. Yes. Well, the boot script. Yes. So let's have another quick look, brief look at the boot script to wrap things up. As I said in the first getting started video, boot scripts should really only be used on developer machines. Usually only be used on developer machines. And these are some settings that are available. I just discussed the disable email one, which prevents you from accidentally, spamming all your friends. The in-house setting is something that you may want to set if you're working on a developer machine, because it enables additional monitoring and some extra error reporting if you set it to true. So the debug output enable and the prefix are actually used to enable debug output, and that's something that I should probably discuss in a separate video. But there's a tool. It's called Debug View. I'll just start it briefly here. This is the tool, and when you're running your flow and enable debug output, Debug View will hold a nice trace of what's going on, so I should probably demo that in a separate video and also explain what the prefix here is about. Check globals is it's a facility to monitor accidental assignments or accidental writes and accidental reads to the global space, the Luas global space, which usually indicates a big mistake somewhere. What you see here, if that in-house is true, we tend to enable debug output and also enable globals monitoring, and they sort of go hand in hand. And it's a good way to see if anything strange is going on. SQL profiling controls is something for a separate video as well, but if you have Debug View configured correctly and you set this one to true, very briefly, what it does, so by setting this simply setting this to true, what it does after each request, all the SQL statements or query statements, whatever, that took the most time, relatively speaking, will be shown here, and you'll see how much time they took, how often they were called, etc., etc. This could be another idea for a separate demonstration video. I don't know. We'll see. Something I realized after the earlier getting started video is that there are actually some newer settings as well. So I'll quickly go through them because they might be useful. So there are these two settings: session debug and conduits debug. If you set them to true and are using debug view, you'll get more information about what your flow is doing to your session context. So you'll see what's being read, what's being written, and can be very useful if you're lost and you need to debug stuff. Last but not least, these are really new, 2017-ish new, and the same holds true for these settings. These are preliminary, so don't use them, but these are interesting. If you set, you can actually name a flow log file here, and Flow will keep an application log of what every user is doing in every session. So you can actually trace how a flow session moves from step to step. But you can also see all the asynchronous calls that are being done, and there are so it's a really nice way if you need to analyze how your flow applications are being used, give it a try and see what you think. So the monthly setting, it's just a Boolean, I think. If you set it to true, then your flow log file won't be one huge large file, but it'll actually be closed. There will be a separate log file for each month that the system is running, which could be, which keeps them, which ensures that they don't get very, 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 very large. It makes them more manageable. In any case, these are the boot settings that I wanted to show you. And I think that wraps everything up. If you have any questions, let us know. Post them on our mailing list or put them in the comments. I hope this has been useful. And well, thank you for watching, and hopefully till the next video. Bye bye.